Hello everyone, welcome back to another video. So today we will see solutions for first six problems of Codeforces round 918 due 4. I was able to solve first six problems during contest, so I will explain just first six problems. So let's just move on to first problem. So first problem is named as odd one out, and in this question we are given three digits A, B, C, and two of them are equal but third one is different than other two, and we have to find the digit which occurs exactly once. For example, in first we are given 1 to 2. 2 occurs twice where 1 occurs once only, so answer of this is 1. In second test case 4 3 4, 4 occurs twice and 3 occurs only once, so output of this test case is 3. So let's see its solution. It's pretty simple. There are basically we can just use three if else, and if first we can write if a equal to b, the output of our program should be the third digit, which is c. Now if b equal to c, the output of our program should be a, and if a equal to c, the output of our program should be b. So this we just need to check these three conditions and the program will work. This was pretty simple. And if you see the number of correct submissions, 28,000. So I guess all must have solved this question. So let's move on to second question. Now in second question we are given a 3 into 3 grid, and uh, the grid contains only a, a B and C, and this kind of grid is known as Latin square if in each row the letters ABC appears once and in each column letters ABC appears once. So for example, we are given a grid in where in first row is filled with ABC, second row is filled with CAB, and third row is filled with BCA. Now if you find all the elements in each row, each column, they are all odd unique, and they are A, B, C. Now uh, we are given that grid, but one of the space in the grid is filled with question mark instead of ABC. Now we have to find uh, we have to replace that question mark with a character from ABC, such that after replacing the whole grid, it's a Latin square. Now there is just one simple observation. If we say this is a Latin square, and we see it. Now if you see in this question, in this example, if A is present once in every row, the total number of A's in the whole Latin square will be equal to 3. Similarly, the total number of occurrences of B should be equal to 3, and similarly the total number of occurrences of C should also be equal to 3. Now if we are, one of the block is replaced by question mark, we can ignore that question mark and calculate all the occurrences of ABC in other other blocks of the grid, and if one of the and we have to print the one character which has occurrence 2. For example, in first case, B occurs thrice, C also occurs thrice, but A occurs only twice, and so we have to replace that question mark with A such that it satisfies this condition. And similarly, in second, uh, we have to replace the occurrence of A is 3, occurrence of C is also 3, but the occurrence of B is 2. So replacing question mark with B makes the occurrence of B equal to 3. So for implementation, you can just use a simple character to int map, but I did some I I used another approach, which is just iterate through each row and calculate the occurrence of A, B, C, and which has zero occurrence, I will just return that character. So this was the solution for second question. Let's just move on to third. So in this question we are given n buckets, and each uh, bucket each ith bucket contains AI wooden squares of side length 1, and we are asked to of build a square using all the given squares of length 1. Now let's take first example. No, let's take just second example. So the array size is 2 and we are given 14 and 2. So now the total number of squares which are there are 16. Now we have to build a square of using these 16 blocks of length 1, and um, if we can build such square, we have to print yes, or else we have to print no. Now let's say I build a square of length 4. For building a square of length 4, I require 4 into 4 16 blocks, and if I am building a square, let's say of 5 length, I require 5 into 5 25 blocks. So the sum of all the blocks which we are given should be a perfect square. Then only we can square of build a square. So in this question, basically we have to calculate the total sum, and if it is a perfect square, then we have to print yes. If it is not, we have to print no. So let me show you my code. So first I took an input, then vector input, and calculated the total sum, and then I use sqrtl of I calculate square root of sum, and if t into d is equal to sum, I will print yes, or else I will print no. Now there is also some problems with sqrt. You should not use this sqrt because it basically works with double data type, so it might give some precision errors. So you can write your custom square root function using binary search, and you can find that type of template on CP algorithms, or you can just implement it yourself if you know binary search. So this was third question. Now let's just move on to fourth. So in this question we are given a string s, and the string contains only letters A, B, C, D, E, and A are the vowels and B, C, D are consonants. So there are two syllables in this language, CV and CVC. So CV means a consonant is followed by a vowel, and CVC means a vowel with consonant before and after. And for example, BA, CD, and BAB are syllables because it matches one of the patterns as CV or CVC, but A, EDA, BAB are not. Now we are given a string. A word in a language is sequence of syllables, and Lura has written a word in the language, but she doesn't know how to split it into syllables. So we have to break them into syllables For example, we are given, let's say, a string BA, CED, BAB. Now we can break it in such as BA, CED and BAB, such that each of the partition represents a syllable CV or CVC. BA represents CV, CED represents CVC, BAB also represents CVC, and we just represent a partition by dot. So we have to output this kind of string for input this string. Now so here there is one important observation. Let's say what are the possible combinations of two consecutive syllables? It is either CV, if I say two consecutive CV, other is CV, then CCV, CVC, other is CVC and CV, and CVC, CVC. Now, if you see here that the consecutive difference between two vowels is 2 here. Here also it is 2, here it is 3, and here it is 3. So consecutive difference between two vowels should always be either 2 and 3. Now adding CVC or CV is what this question main logic of that question is how to add CV or CVC. For example, let's say I have BA and I also have BAE as one of the options, BAD. So should I add dot after A, or should I add it after D? Because C, this also is a syllable and BAD is also a syllable. Now that can be identified using the consecutive difference logic. If you see one of the test cases, let's say this first only, I have BA and C, B, A, B. Now this is the first vowel, this is second vowel, and this is third vowel. Now the difference between these two vowels is 2. So this follows a CV, CVC or CV, CVC type of pattern. So I have to add dot after the first vowel itself. So I will add here a dot. Now I will for next, let's say E and A are consecutive vowels. The difference between this is 3. Now this type of presentation is CVC, CV or CVC, CVC. So after the vowel and one consonant, I have to add dot. So after E, there we have to skip one consonant, which is D, and add dot here. So output string becomes VA dot CED dot BAB, and this is the answer. So we have to match this type of pattern based on the consecutive difference between the difference between consecutive vowels. So let me just show you my code. So first of all, I have initialized a previous integer. So previous basically stores the value of index of previous vowel. So if a vowel is detected, so I just assume that it might contain all the characters from A to Z. So I just wrote all the vowels from I to U, and if previous is equal to -1, I will just make previous equal to I because it is the first vowel itself. And if um, else I minus previous is equal to true, so these two conditions. So in this type of question, in this type of condition, I have to just add dot after the vowel, previous vowel itself. So I will just mark as MP of previous as 1, and or else the difference is equal to 3, and I will mark next consonant of the previous vowel as 1. Now also update the previous as I, and for each I am iterating over and loop, and I will print s of I. But if I have that I as marked, I will also output a dot, and just finally I will just print the backslash n. So this was the solution for problem D. Let's move on to problem E now. So this is a very interesting question. Let's just, so we are given an array of length n, and we have to find out two indices L and R such that the value of sum of all elements at odd positions must be equal to sum of all elements at even positions. So let's say I have A1, A2, A3, A4 and A5. Let's say I have taken L as 1 and R as 5 itself. So A1 plus A3 plus A5 should be equal to A2 plus A4. So we have to find at least one pair of L and R such that it follows this condition, and if we can find such two indices, we have to print yes, or else we have to print no. Now in this type of question, always remember, whatever equation you find, try to make it try to resolve the equation in easier steps. For example, I can make this A1 minus A2 plus A3 minus A4 plus A5, and this should be equal to 0. Now if you see what I have written, so for L to R, I will just add first element, then subtract second element, then add third element, then subtract fourth element, and add fifth element. So this, if this kind of sum is equal to 0, then we can say that there exists such LNR, and we have to print yes. But we cannot iterate for all L to R, because it will be, and the solution will become of order n square, and n square in this constraints will give TLE. Now there is a subarray technique which is used, and I will try to explain it. So A1, let's take a bigger array, A5 and A6. Now if I have to check that A3 to A6, let's say from L3 to R6, the sum A3 minus A4 plus A5 minus A6 is 0. Now how to check this without n square loop? Can if we add this also in this, A1 minus A2 plus A3, so this will not be equal to 0, and this is total and we have to subtract this from this. Then we can get this subarray sum. Now after adding this total, this is total and I have to subtract this one, so I subtract a1 minus a2, and this should be equal to 0. So if uh, so this upper first equation represents total sum, second equation represents this sum, and this sum should be equal to 0. That means total sum and this sum should be equal to, should both of them must be equal. Now let's say I take a prefix sum of a1 and this type of prefix sum where I add odd indexed element and subtract even indexed element. So I just initialize sum at 0 initially, and for at whenever I am at index 1 I will add sum will become a1, and whenever I am at index 2 sum will become a1 minus a2. Now after adding each element I will store that I have visited such sum, or I have uh, got that such sum at this point of time. Now if I again go to 6, at this point the sum will be this equation, a1 minus a2 plus a3 minus a4 plus a5 minus a6. So if now I will check that m I have if I have the MP of sum as visited, or I got this sum already, then I can say that the difference between that sum and the sum at current index will be equal to 0 because both of them are equal. Then I can say I have found that ln value of such pair ln r which can be equal to 0. So this kind of uh, in this question you basically have to do first this equation simplifying, and then this this is a sub-array technique. So if I have visited two sums at two equal sums at two different indices, that means I can say the difference between the sub-array between those two elements will have total sum as 0. So I can say this sub-array as uh, we have to only find that L and R should be equal to 0. So this kind of technique is known as sub-array technique, and we have to use this, but just modify our prefix sum as a1 minus e2 plus a3 minus a4. So alternate plus minus. So let me just show you my code. So I have used a map MP and took the input array and initialized the sum. So whenever I percentage to I is even, I will add a of I into sum, and if it is odd I will subtract a of I. Now if I have already visited this sum, I will just print yes and return, else I will mark that sum as visited. Now also we need to consider that 0 can always be visited. If the prefix sum itself is 0, I can make L to R uh, sum as 0 because L here can be 1, and we don't need to check previous because the prefix itself is 0. So I have also marked 0 as 1, and this is not required because adding sum plus AI sum minus AI, or I would have done sum minus AI sum plus AI, it is almost it is equivalent to this, so no need to do this again. So this is also a pretty simple question, but there are some this kind of observations which you have to make. Now let's just move on to sixth question. So in sixth question, what we are given pair n pairs, and for ith pair, ith person goes from point AI to BI, and we are also given that BI is greater than AI, and at each it can move 1 unit per second until they reach point BI, and once they reach point BI, they will just stand there, and when two people meet, they will greet each other, so we have to find total number of greetings, and uh, a person can greet other people even if they have reached their final point. So we are also given that all the integers, all the 2n numbers, means a1 a2 up to an and b1 b2 up to bn, are distinct. So let's see one first test case. So we are given two integers 2 3 1 4. Now at t equal to 1, first 2 will reach t, and this 1 will reach 2, and at t equal to 3, t will remain at t, but this second will go up to 4, but at t equal to 2, 2 was at position 3, so these two persons will greet each other, and the number of greetings here total are 1. So this was the first test case. uh, I hope you have understood the question. Now let's let me there are basically three main observations over here. So they have given that all the integers given are distinct. Now let's just take some example. Let's say starting points of, I have taken 4 persons, and starting positions of all persons is 1 2 3 4, let's say, and ending position might be anything. We are just trying to find I'm trying to explain what first observation is. Now all the people will in move parallelly. Now 1 2 3 4 at t equal to 1 will reach 2 3 4 5. Similarly at t equal to 2 they will reach 3 4 5 6. So the difference between positions of any two persons will remain same whenever until they are traveling. So they cannot greet each other until they have until one of them reaches its uh, final point or ending point, which is BI. So greeting will only occur at final point of one of the greeters, one of the person. So this was first observation. Now let's just say second. Let's just take again. I have taken 1 3, then let's say -2 and 8. Now the first person, the second this person who has the person who has ending point 3 will always will greet all the elements which have bi greater than itself. So for here, if the first person has ending point 3, now whenever this person reaches 3, the second person at some point of time will reach this 3, so they will greet each other. Now I add another element, let's say -3 and 100. So this third person will greet both of these persons. Similarly, this 8 can greet this 100, and we are basically finding which person is standing at its ending point and which person is traveling and greeting other person while traveling. So for 3, uh, person with ending point 8 and 100 are traveling but 3 is standing. Similarly for 8, uh, person is traveling whose ending point is 100, but at that point 8 is standing. So for 3, all the elements which have greater value than 8 greater value than 3 will be greeting 3 while traveling, but 3 at that point will be standing. So this was second observation. So what this observation makes you, what this observation is, uh, why this observation is important? Because now we can sort all the pairs using the second using the second value. So we have to write a custom sort using the according to second value. Now third observation is, let's say I have element 1 3 and 2 4. Now for 3, the persons who have greater value than 3 might has the chance of greeting the first person. Now in this case there will be no greeting, because after t equal to 1, the position of first person will be 2, position of second person will be 3, and at t equal to 2, position of first person will become 3 and position of second person will become 4. Now the greeting will only happen at the final point of first person, but when first person himself reaches the his ending point, second person has already crossed the uh, ending point of first person, because the value of the time taken for first person to reach 3 is 3 minus 1, which is 2, and uh, the time taken by second person to reach position 3 is less than 2. So this two second person will already cross the ending point of first person, so there will be no greeting of both the persons. And we have to also check this condition. So this is third observation. So using this all three observations, we have to find the total number of greetings. Now let's just see the code for better understanding. Yeah, I also tried how can I do it. So I will first sort all according to second observation. I will sort all the vector pairs using second value. So I have to write comparator, and for each I from n minus 1 to 0, I will iterate and insert value of first element of the pair, and whenever I reach uh, whenever I'm at position I will find all the elements which are less than a of I dot first, and so that number of persons will greet ith person at ending point of ith person, and I will just add the total number of elements which are less than 1 or a of I dot first into our answer, total number of whatever answer we are storing. So I just took n pairs input and I sorted all of them using a custom comparator where I just returned a dot second less than b dot second, and here I'm using ordered set. Now what ordered set is, in normal set I can store all the values in sorted manner, but I cannot find the index of this tree. So what basically index of 3 is, it is total number of elements less than 3 plus 1. I can say if it is zero based indexing, it is total number of elements less than 3. So I cannot get this in normal set. So in the set provided in STL, so what I have to use, I have to use a policy based data structure. So it is a tree based set, and this set also provides order of key function, so which returns number of elements which are strictly lesser smaller than a of I. So for if I just print order st dot order of key of 3, it will print 2 as 1 2 are strictly smaller than 3. So I used the ordered set, and I had to add these lines of what you can policy based data structure. And if I'm iterating from n minus 1 to 0, if st dot size equal to 0, then there are no options. For last element there is no option where him is, he is greeting other person who where the last person is standing at end, and all the other persons who are greeting him are traveling. So there are no such options. And else I will just calculate st dot order of key of a of I dot first, and add those greater elements, add that value to answer, and I will just insert a of I dot first in ordered set, and finally print answer. So this understanding this question is, if you understand this question, it is good. And if you struggled with implementation, or you don't know policy based data structure, this might be a uh, good lesson to learn that topic. So if you want, you can search this in, you will find many resources of learning this on internet. Probably you can search on CP algorithms, or any, you can also search it on YouTube. So this was first 6 problem. I also tried G, but I was failing in one of these cases. So this is a graph based problem, and if I'm not able to solve it in contest, I shouldn't explain it to you. So I guess that's it from my side. Thank you for watching.